Assalamualaikum warahmatullahi wabarakatuh. I will be the first presenter for this video presentation. My name is Muhammad Anaki Putra bin Awang Abdul Hisham. My matrix number is 2410271. I will explain about part A, which includes the both of the problem statement and mind map from brainstorming session. First, the problem statement that we can conclude from the situation is a commercial building wants to increase the current volume of water tank by 10% to 20%. The existing dimensions of the water tank was 16 meters tall with a radius of 7 meters. Then, the objective for this project is to get the maximum volume of water tank, which is to get an additional of 20% from the existing volume of the water tank. But there is one condition, one restriction, which is the new height must be within tolerance of plus minus 0.3 meter. It means that we can have a variety of change of radius that will be discussed on the next presenter. To add on, the new weight of the water tank is expected to be within 30 kilonewton to 40 kilonewton. Depends on the real-time capacity. The next one is for the mind map. We discuss a few things that need to be considered on this project. The ideas are from the needs of a client, which for this topic, a commercial building. The first one, new volume. The client needs an increasing 10% to 20% of the previous volume tank by using formula V equals to pi r squared H. The second one is new weight. That the new weight must be within 30 kilonewton to 40 kilonewton. And the third one is supporting beam. The supporting beam is calculated by using the formula of shear force and bending moment, which are, the first one is change of shear force is equals to the integration of weight applied with respect to x, and the bending moment m equals to integration of shear force with respect to x. And the last one is the same height as possible, which it can be tolerated by plus minus 0.3 meters. And that's all for part A. I will pass to the next presenter.
Assalamualaikum. I am Ahmad Shazwan bin Shamsuddin, matric number 2410273. So in this part, I will explain question B1 about the coding to find the possible dimension of the new water tank. So the info that was given to us is the original radius and original height of the previous water tank, which is radius equal to 7 meter and also height equal to 16 meter. And it was also given the range of increment for our new volume of water tank, which is between 10% to 20% of increment. So this info we can use to find the volume of the previous water tank using the formula V equals to pi r squared H. After getting this previous volume, so we can find the new volume of water tank. So in this coding, we choose to use the increment of 20% of the new volume of the tank. So the formula we use is V new equals to V plus 0.2 V. So the V here is actually the previous volume of the water tank. After getting the new volume of the water tank, we can use to find the new radius for our new water tank using the same formula also. However, we just arrange the formula to make our radius as the subject. So it's also mentioned that we can use the height for our new volume of water tank with the tolerance, which is plus minus 0.3. So we can use that to find our minimum radius and also maximum radius. So the formula for the minimum radius is R new 1. So we just sub the value of H1, which is equals to 15.7 meter, which is the minimum radius, minimum height of our new water tank. And the R1, which is the maximum radius, we just sub the value of the H2, which is the maximum height for our new water tank, which is 16.3 meters. So after getting this value, we can use it to plot our graph. But before that, we will find the weight of our new water tank using the formula weight, which is W equals to mg. However, the mass, we can find it by using the formula of density. And in the row here, we use the density of water, which is 1000. After that, we can start to plotting our graph, which is graph radius against height. Then, after getting the graph shown is decreased linearly graph. So this graph is proven by the formula of volume, which is equals to pi r square h. So since r and h in the same side, so when height of the water tank increase, so the radius of the water tank will decrease. So it shows that our graph is correct. So that's all.
My name is Ahmad Hakim Hilmi. My metric number is 2413815, and I'm going to discuss about the design calculation of the weight distribution on the platform. So we're going to apply the integration method. Firstly, we have negative W equal to dV over dx. So we have to know that negative W is weight applied, and V is shear force. So to get V, we have to integrate negative W over dx. We got negative Ws plus C1. Then we have also V is equal to dm over ds, which is dm. M is bending moment. So to get M, we have to integrate V ds. Here we got V is negative Ws plus C1. So we just put in here and integrate it. And lastly, we got the bending moment is negative 1 over 2 Ws square plus C1s plus C2. We have first S equal to 0, so M is 0. And second is S equal to L and M equal to 0. So we can put insert C2 constant 2 is equal to 0. So that's first. Then we put the second value into the same formula. So and in this formula, and up we got C1 is equal to 1 over 2 WL. So we got M is equal to negative 1 over 2 Ws square plus 1 over 2 WSL, and V is equal to negative Ws plus 1 over 2 WL. So when we have the formula, we can put the real value lah. So based on our discussion, we got the weight is this 2.1 2.8995 to 4 kilonewton. Radius is 7.7410 meter, and the area we put the value in the formula pi r square, and we got the 188.2539 meter square. So to get the Q, which is weight distribute, to get the Q, we have to put W over A, and after put we got this 154.0207 kilonewton per meter. And now lastly, length of the support system, which is 2R plus 0.4. So lastly, L we got 15.8820 meter. So that's all from me. Thank you.
My name is Muhammad Afal Hafiz Muhammad Zailin, and my metric number is 2418205. I will explain for question B number 3, which is the question asks about the coding and also the graph for shear force and bending moment. So first we will go take a look for coding first. So as you can see at the slide, the first line of the coding is CLC. CLC is the coding for clear the command window, which is not too important. So we will go straight forward to line number 3, which is R. R stands for our radius. Our radius is 7.741 meter. And next line is our weight of distributed load, which is 154 kilonewton. And the next line is our length, which is 2 times r plus 0.4 meter. Next, our constant is 0.5 times weight times length. And next is our x. X represent the position along the length of the beam. And next line is our V, which is shear force. Line number 9 is our bending moment formula. Both shear force and bending moment formula as a function of x. And lastly, the line number 10 to line number 18 is our coding for the graph. That's all for the coding. So let's continue to our graph. So first graph is graph for bending moment. So as you can see at the slide, the peak of the graph is at 8 meter, which is shows that the largest bending moment at the middle of the beam. This is the graph for shear force, which is the graph is a straight line. This indicates the shear force decrease linearly from maximum positive value to negative value. That's all.